Before we go into more detail about service work, let's see how a Kraenzle heat exchanger works. The water is forced through a heating coil by the high pressure pump. The heating coil is approximately 38 meters long and has a capacity of 5 liters of water, with the heat output being a maximum of 90 kilowatts. The fuel pump sucks the fuel from the fuel tank through a filter and delivers it to the injection nozzle. The fuel pressure is indicated on the fuel pressure gauge. A fan draws in the cold fresh air through the bottom of the unit. The air is first forced through the underside, thereby cooling the bottom of the burner. This simultaneously causes the airstream to heat up. From the underbody, the airstream is pressed into a ring shape via the intermediate mantle into the upper collecting chamber and from there into the mixing device to the combustion chamber. There, finely atomized fuel is injected via a nozzle and mixed with the air. The electrodes positioned below ignite the fuel-air mixture. The cold water enters the heating coil in the inner coil. The temperature in the heating chamber is lowest in the upper section. The water heats up only slowly and enters the lower combustion chamber well preheated, where it is fed into the outer coil. The Kraenzle burner technology means that there is no dew point, and due to the slow heating of the water, there is only a small amount of calcification. The exhaust gas temperatures leave the exhaust stack after the heat exchange process with only approximately 140 to 160 degrees Celsius. What happens inside the heat exchanger we will now see using our flame simulator. On the left side, we see the cutaway model, where the following elements are clearly visible: the heating coil, the burner motor with the air blower motor on one side and the fuel pump on the other side. Then the inner mantle and outer mantle, and it is in between these that the fresh air from the blower is fed to the mixing unit. On the right, we have the flame simulator, where the same masses are found as in the real heat exchanger. The difference is that in the flame simulator, we do not have a heat exchange surface of 2.4 square meters. This explains the extremely high outlet temperatures of approximately 600 degrees Celsius. On the far right are 3 mixing units. The top mixing device is equipped with an intact fuel nozzle. In contrast to the flame simulator, a relatively large amount of black soot can be observed despite a correctly atomized nozzle. The reason for this is that the ratio of oxygen and fuel is not correct. With the middle mixing device, the fuel does not ignite because the nozzle is worn or does not allow fine atomization from biodiesel or dirty fuel. The lowest mixing device has a hairline crack in the brass nozzle housing. The reason for this may be that a technician over-tightened the nozzle. Thus, the heat exchanger works fine, but from time to time there is a smoke trail coming out. This leads to sooting of the burner. Let's look at the sequence of service work. Visual inspection regarding the general condition of the device, for example, defective cables, connectors, and so on. Then clean the fuel filter and, if necessary, also the fuel tank. Check the fuel nozzle and replace if necessary. Adjust the ignition electrode and replace if necessary. Check the height adjustment of the mixing unit. Check the fuel pressure and adjust if necessary. Check the soot pattern, check the CO2 levels, and determine efficiency. The following material will be needed prior to service: a screwdriver number 3, Phillips screwdriver number 4, Allen wrenches 3, 4, and 5 mm, water pump pliers, box wrenches 12, 14, 16, and 19 mm, and lastly, Teflon tape. Now, let's see how to perform the necessary work. First, disassemble the fuel filter housing, clean the filter element, and replace it if necessary. If the filter screen is very dirty, empty the fuel tank, clean it, and refill it with clean fuel. Clean the filter housing and reassemble it. Dismantle the aluminium rails. Dismantle the fuel line with the 12 and 14 wrench. Disconnect the ignition cable. Dismantle the flame monitoring photocell. Remove the mixing chamber. Now we replace the fuel nozzle. Caution! Please do not touch the fuel outlet of the fuel nozzle. If necessary, also replace and adjust the electrodes. The easiest way to do this is with a 3 and 5 mm Allen key. Use a 3 mm and a 5 mm Allen key to set the correct distances of the electrodes. This is the best procedure because you cannot reach all necessary spots with the calipers. The mixing unit is then reinstalled. If the factory setting of the air regulation has been adjusted, it must be checked. For example, for a Therm 1165-1, proceed as follows. Screw in clockwise as far as it will go, then turn back 1 1/4 turns counterclockwise. Screw the lock tight and seal it again with red paint. To adjust the fuel pressure, remove the cover and set the pressure according to the operating instructions. The UVV inspection of the burner after a service includes the following measurements. First, determine soot value according to Baccarat with this soot pump. Secondly, determine the CO2 content. Thirdly, quantify the efficiency of the burner. Now to the procedure for the soot control. The burner must be in operation for at least 5 minutes. Then insert the filter paper strip into the slot opening of the soot measuring device and clamp it tight. Then insert the probe for sampling into the exhaust gas connection and clamp it in the middle of the flue gas core flow. Then take the flue gas sample by implementing 10 full suction strokes in the core stream. Each suction stroke should last approximately 3 seconds. Then evaluate with the comparison scale, holding the soot spot under the corresponding gray spot and read the soot number. At least 3 measurements are required and the arithmetic mean should be rounded to the next full number. Then, the CO2 value and the efficiency is done with an exhaust gas measuring device, which we have done with a Testo 320 in our example. There, the limit value of CO2 is 9.5 to 10.5 carbon dioxides. The efficiency has to be 91% or higher.